All right, Sunday crew. Stopped today. My part one test case only passes sometimes, and I have no idea why. That's really unfortunate. I think today gave quite a few people trouble. I don't know that the stats are representative yet. It is about halfway through the day, I guess. Maybe a little more. But if we look at the stats, I bet today is a drop-off. Guess we're dropping off. I don't know. We'll see. We'll see what the drop-off today is. I'm curious because it seems like if you don't already know what to do, then you won't make the algorithm. But we'll see. We'll see. We're gonna try to do it today. That stuff. I don't think I did anything with yesterday's off stream. I think I just left it. Which is wonderful. I love taking some time to myself. So we are on day 12. I'm gonna make my little day 12 directory. One of these days I'm gonna get around to doing the cargo generate. Day 11, day 12. Cargo generate template. That day was not yesterday, so it is what it is. Did I click the go live button? I did. Okay, cool. You know, sometimes it's like the like, I think I did something and then I have to actually go back and check if I actually did the thing. Okay, so day 12, code dot. Let's not update VS Code. Let's go into lib and basically delete everything. So today, I read the question right before stream and whatnot, and today is a graph traversal. So we have options, I think, none of which are particularly good in terms of what extra libraries and stuff to use. Puzzle input, we'll just say this is like a U size or something right now. Okay, so everything's at 0. We've zeroed out. We need to grab the problem. I believe this is the test. This is the first test input we should start with because it's the most simple. Apparently it is street cleaning day, so that's happening. Test input, we'll drop this in here. So I'm gonna start changing this to capital input because that's what it's supposed to be, and Cargo keeps warning me, and I even ran into some issues that would be confusing to people. So this is node-node in the input, right? We're going to do a non-parser. It's going to split by this. We're probably going to insert it into a pet graph or a hash map or something like that. I feel like inserting it into a hash map is our best bet today, where we have keys that are the nodes and values, which are the nodes they connect to. We need a parser. The parser is going to be super simple today. So we end up with something that looks like this. I think that maybe for us, it's going to be like start with a value of A, B, and then A with a value of maybe like start, C, end. B with a value of start A and D and stuff like that. And then we'll kind of figure out how to build that up. Given these rules, there are 10 paths through the cave system. So this is the kind of like output that we need to get. So far, you're planning the exact same thing I'm trying. So the thing with my first thought was pet graph. And pet graph has two modules. One is called visit and one is called algo. And I don't think that any of these others are related. There is neighbors. So we could do this as well, right? It may be useful for us to do this, but also we can construct the neighbors with a hash map, so I'm not sure we need the graph structure on top of it. I don't think that neighbors really gets us anything in that sense. But pet graph has depth first search, breadth first search, depth first post order, and topological, and it has some other things. The problem with this is that it is non-recursive. So we don't really get the cycles that appear in our input. So if we look at like the graph here, we get start A. So the rules are capital A's are big rooms. We can revisit them. Small letters are like once-off rooms. We can't visit them twice. So if we go to start and we go to A, we can go to C, but we can go back to A and then we can go to end. And then even then we can do like start A, C, A, B, A, end. It's, yeah. So we don't get that from any of our pet graph algorithms. As far as I know, anyway. Maybe we do. And then algo will give us like all the simple paths, which I think are direct routes from to. There's no way for us to like weight the rooms. You don't need pet graph. I'm aware I don't need pet graph. I'm just talking through my thought process. Start and end only once, yes, for sure. So capital A is a big room. We can visit that multiple times. Start and end only once. Small letters, like lowercase letters, only once. But we don't have a way in pet graph to emulate that. So even if we were going to use pet graph, there's no ready-made way for us to do that. Which means that doing it ourselves makes more sense anyway. Using vect2q will suffice. A vect2q? Really? If I could spell. What do we need a ring buffer for? Like, what does this get us over a regular vec? Anyway. So the way that I'm thinking about doing this is basically a recursive thing where we start at start, right? And then we build up like a B tree map or something like that. And we start with just start, and just start has an insertion, and then start A has an insertion, and start B has an insertion. And then we go to A, and we could be like, okay, we can go to either 3. It's not good on popping from front. I mean, why do we need to pop from front? We never need to pop start off, right? So let's start writing the parser to get started anyway, because we do have to go through the input. There are 10 total paths. It doesn't give us the answer that we're looking for. That how many paths through the cave system are there that visit small caves at most once? So I'm taking that to mean that we have to get to the end. I don't think that the first one, I guess all of these show the end, right? So there's 10. So if we get stuck in a cave, it doesn't count. So this will be 10. Puzzle input will be let input nodes equals separated list 1 pairs. What is it? Is it separated on the left or separated on the right for now? Separator is the first argument. So we'll be separated by a new line here, and then we'll have pairs. And then pairs, input, string slice, and I guess it doesn't really matter. We do have delimited by. There we go, pair. Pair isn't really what we want. Separated pair, there we go, first, second. Separated pair, and then we got alpha 1, tag dash alpha 1. And this should give us separated list 1, new line, input here. If I could type, that would be great. Separated pair is something we haven't used before. It's basically separated list, but for a tuple. Alpha 1, something we need to import. I really don't have tag in here right now. Keep in mind, vegan, that I don't do advent of code like style problems throughout the year, so I'm not really a competitive programmer or anything like that. I'm only like an industry programmer, so I don't recognize the algorithms and techniques applied to competitive programming problems as fast as other people would. So separated pair, debug nodes. So if we just cargo test, It fails, and we didn't apply puzzle input, so input nodes equals puzzle input. Input. This is unwrap because it has to pass. Okay, so what we end up with here is a bunch of tuples. So we get start A, start B, AC, AB, BD, A end, B end. So let map equals B tree map new. I guess we could potentially B tree map from. What would a B tree map from do with multiple keys that have values? Is my question. I don't actually know the answer to that, so let's find out. Nodes. Probably type annotation needed. Oh, it's from from a vec is not okay. Okay, can we do from a slice? It's possible that every node has multiple destinations. Yes. The question I had is basically, does the from version of btree map, which doesn't apply to, I guess, slices or vecs at this point, because you need a static amount of items here. Would this from, if we had multiple keys of the same value, allocate it into a vec for us or not? But it doesn't matter because we can't use this anyway. Let mute map the B tree map of string slices to vec of string slices. Map dot. I guess we'll insert fail if it already exists. I guess entry is what we really want. Anyway. Entry. For nodes, for A, B, and nodes. You can use many elements, it's const generics. Okay, yeah, so I could do this if I wanted to pull it in and actually do the calculation in a const position. But that would mean using like include stir and then doing this parsing. We still can't do a vec though. We still need like an array of a set of numbers, right? So we need to calculate that at compile time if we're going to use const generics for that, right? Because we don't know how big the array is going to be. I can go back and try that again. No, that's different. B tree map from nodes, right? And then we don't have any way to get this. Like, it wouldn't work, I don't think. Because we can't do it with the reference. We have to pass the actual owned thing in. Anyway, if y'all know of a way to get a vec into a B-tree map from that does a vec of strings, then let me know. Or insert vec b and modify unit v dot push b. We don't return anything here. In nodes is not mutable. Is that the problem? Use that to remove because I debugged it. Yeah, perfect. That will be very difficult. A legal way is A to B and B to A. Looks exactly like hash map. It is hash map. It's just an ordered hash map. It looks like hash map because it is hash map. The only difference between hash map and B-tree map in Rust is that B-tree map is ordered. So if you iterate over it, you get everything in order. And then for a hash map, you're not guaranteed any order. Node.intuiter. Do we actually need that? Rust Analyzer isn't even telling me that there's a problem there. Why do I not need... I guess this comes in as mutable? Huh. Okay. Today I learned. I guess that makes sense. Like, and modify would need a mutable reference to the back. I just wasn't where my head was at. Okay, so we have A, B, and start. We still need, what, D? Let's look at the test input. We never use D, right? These are bidirectional connections though, right? So theoretically our hash map should have a B to D. The fact that it does have a B to D. It doesn't have a D to B though. So we need to flip these all and do it again. So that we have all the nodes. Why didn't that work? Keyboard messed up. So now we have all the nodes and all the nodes they connect to. We do have to start at start, and we do have to end at end. So end, technically, like we're gonna go to end, and end needs to be empty. So maybe we set that up a priori. Yeah, adding reverse link will make things easy. Yeah. The other thing that I'm gonna do here is if I guess end doesn't show up in the beginning ever, does it? Is it in the beginning of any of these inputs? No. It shows up in the beginning here. Okay, so we need to do both. I fixed the flakiness of my test. They fail every time now. Nice. that is progress, I suppose. I feel like I want a special case end here. And make it empty because it can't go anywhere. And then maybe use that as the terminating factor. For the recursive algorithm. So basically what we're doing here is if we get end in either case, because in one of these, it actually does show up in the beginning. Then what we want is actually the empty vec for end because it can't go anywhere. So start can go to A or B. A can go to any of these except for start. Because nothing can go back to start, right? So we can encode that here too. So else if A equals, not A equals start, is it? It's only on the other direction. So here it's else if B equals start, else whatever. And the other one is going to be else if A equals start, right? So hopefully this pulls start out without affecting too much. Did not. What did I do wrong? This is A. So now we've pulled start out so you can't go back to start. The way is every time from start to end, so start and end need a minimum of one connection. Yes. We'll start. Yes. You mean one connection as in a path through, right? The thing that I'm doing here is I'm fixing up the B tree map so that start has values it can go to, but values don't have a start value they can go back to, right? Because I don't think we're allowed to go back to start after we start, right? Like we start once and we end once because they're lowercase. And all I'm doing here is fixing up the data to make sure that that's true, regardless of whether we check. No, you can go through end twice. I don't see that in any of the test input. Right, because if you could go back to start, yes, there can only be one start and end. Yes, that's what I'm saying. I'm fixing up the input such that even if we write our algorithm incorrectly, we can't go back to start because none of these nodes now connect to start at all. From like if we land on A doesn't have a path back to start. End is a small cave, so no twice. Yes. Technically, because these are lowercase, if we were checking for lowercase, that would also work. But instead of special casing start inside of the traversal algorithm, I special cased start when building up the data structure. That's the only change. Okay. So we've got this B tree map, right? We need to write a recursive function. So maybe function step. I don't know what step does yet, so I'm just going to leave it here. So let me just write this out for a second. Nodes dot. Does btree not have get? Btree has get, right? What did I mess up? Am I not returning this? I'm returning like something silly, aren't I? Usize. Yep. I want to return this btree map. And now lowercase caves can only be visited once. Yes, but that is an algorithmic thing, not something I think I can handle in the data structure, right? So like theoretically, D to B could still be valid, right? Because theoretically, we could go like capital A, lowercase d, lowercase b, end, or something like that. Not in this graph. This graph doesn't have that. But like we can't, I don't think we can do anything else with the data structure to make this easier. So node equals nodes.get start. After we get start, we have to keep start somewhere, right? So some state has to be held. It looks better than my version. What did you do? Also keep in mind I haven't written the algorithm yet, so it may not end up being better than your version. We need to keep some state, which is probably says to me like a fold would make more sense here. Maybe. Let's see. Rust, iter, ator. I've not filtered out any possible ways. Yeah, fair. So what do we have here? I don't think we have like advanced recursive helpers in Rust in the iterator trait. I wonder if itertools has some. Like when I think advanced, what I'm thinking is recursion schemes. This is what I'm thinking of specifically. And not to put people onto Haskell, like, but there is basically a whole bunch of higher order recursive functions. Here's the thing that I wanted. And like, if you work your way through this graph, you should end up with, well, we have the Bardo checker to make this way more complex. Yeah, I don't even know if this stuff is like buildable in Rust. It's just my mental model is built around higher level recursive combinators instead of manually recursing. You'll notice that I wrote a step function here because I think that's how we're going to do it in Rust. But like, there's the idea of the shape of your recursion. And for example, like, what is the shape? Is the shape the same as the output type, or is it the same as the input type? Is it neither of them? And depending on this kind of thing, you can either choose to fold down into a single structure or unfold up into like, we'll say a vec because that's simple. That kind of stuff. I solved it in Rust, so there is a solution. Yeah, for sure. 100%. I'm not saying there isn't a solution. I'm just saying that I don't think we have quite this high level of utility tools to work with in Rust. Iter tools, const tuples equal fold. I think we end up with fold here. This kind of like unfold kind of like generates an iterator. Yeah, I don't think we have any like useful helpers here to actually get this done. We could scan. I don't think we need to scan per se. But if we end up needing to loop and then scan, we could do that. So scan is like fold, except that as you build up the values, it produces those values in the iterator. So like if you were building up, say, a string, right? And you used scan instead of fold. I don't know why you would use fold to build up a string, but you could, right? From a set of characters or something. Then when you fold it up and you had A would get produced in the iterator after scan. And then when you had AB, that would get produced as the next item, and ABC would be the third item, that kind of thing. Which I don't think we need. But we do need to keep some state around. Maybe we can do a B tree map again, right? So maybe we do, what do we do? Maybe we do a B tree map and we keep the segments around. The state needs to be different for each path though, right? So if we visit, but the state is also kept in the chain, so we don't actually need to keep it separately. Like if we go to capital A, lowercase b, capital A, then we will have that in our path. And we don't need to keep that state separately. So we can check the actual path as we're building it up. So we would nodes.get start, right? And then start, that's subnodes, right? This is what this gets us the vec. Yeah. So then we have next nodes. We need to basically step like we need to do something like for node in next nodes step, right? And then this is the call that gets us the recursion. So let's say how do we keep this around though? I guess we only need like a set, right? And then we can build up all of the vecs. I'm kind of stuck thinking about like which data structure to use for the state to like group it up. Because we get start here, right? And if we used like Let's just get started with something. State equals, and then I'll figure out what's wrong. You don't need to keep full paths around, because you just need to return the characters in a tree format. Yeah, the first step is from start to question mark, so the recursion is starting with start. Yes, the recursion is starting with start, and then we build up a tree, basically. The ask how many, not which ones. Oh, am I hung up on the fact that they are telling us that these are all the paths? And we don't actually need to keep that data around? So we could return an integer from this, right? Which would mean that this could be 0 or something. And then... So we would call step with the node, right? Which will be a string slice. And the B-tree map of all nodes. No, the way is not to be needed. Only the count of possible ways is needed. Yes. Okay. So we do this, right? And this returns us like an integer. So when we hit end, basically we return 1. If we don't hit end, if we hit something else and we can't continue, then we return 0, right? And that way we can build up the tree and then pull everything back into a usize. So here we would do step start. And this would be, we get the node, right? Which has to exist. If it doesn't exist, then, you know, we're kind of screwed. And that means that I set something up wrong in the problem. And step would take the next node ID. So this is like dot sum, right? And this is not that. This is next nodes dot map node step node dot sum iter. And then we do need to do a check at some point. So step node all nodes. I don't want this to be an owned B-tree map because we're gonna pass it around everywhere. For help, may rename the constructed B-tree to allowed ways. Yay, Stack Overflow. The constructed B-tree to allowed ways. Yeah, sure. I'll do that. We Stack Overflowed I feel like I'm somewhat surprised at that. This is fixed and should not be modified, so it is like a const. Right. We're not modifying that. I'm passing in a reference, which feels weird. I know that the arguments get... First thing is in recursive is a break condition. Oh, am I just going forever? And I'm not. Yeah, okay. Yeah. That makes sense. What's our break condition? If we're at end, right? If node ID equals and not break, but 0. Else we do the recursion. But we already knew that because if we get end, what we get from next nodes is an empty vec, which we iterate over. We're not blocking any either. We are not. Yeah, I don't see how we can't actually. We have to track the path, don't we? Right. We have to track the path. Because if we don't track the path, if you do a return 0, the else is not needed. Yeah, fair. So path dot concat is non-modifying, and then we do node ID here. Found string. We don't build string, do we? String slice, string slice, string slice, path dot concat. The recursion itself needs to track the path and the visited locaves. Yes. That's what I'm setting up right now. Associated function defined here, concat. Item size, self. Self is concat item. I guess this needs to be a string, right? So this would need to be a reference. Which feels... No, this doesn't need to be a string. Why is this a string? Rust iterator concat. Did I accidentally pull in like path join or something? Slice concat. Hello world concat. 1, 2, 3, 4 concat. Is concat not what I want? Concat isn't what I want. I want to have... Join is not what I want. Connect. What do I want? What did I... What did I do wrong here? Concat is not what I wanted. Path is a vec of stringers. Right, so if we do using a vec and push it, I don't want to push because we need a new one in each of the recursions, right? So if I push, then I need to mutate it, and mutating it would mean I need to clone it first. If I need to clone it first anyway, then I can do like path.clone. I guess we could push. Yeah, I don't mind doing that actually. Let's do that. And then we'll fix it later. This needs to be inside of the this. New path dot push node ID. That's fine. We can do that. I was looking for something that would take is append what I wanted? Is it going to be right there? No, that's mute self. I was looking for something that would basically deal with that for me. I didn't want to mutate it. I just wanted to create a new one, right? So is there a non-mutating version of concat in vec? And it doesn't look like there is for whatever reason. I guess I could just manually clone it, so it doesn't really matter. It's just interesting to me that all of they all are mutable. I guess that's where. Okay, so there's that, and then if node ID equals end, then 1 actually. Else if no, what is this? Path dot includes node ID path dot iter dot all this is going to be 0. So path dot iter dot all node dot, is there like an is? There's no is lowercase, is there? No, I don't want the slice type. I want stir. The stir primitive type. That's what I want. There's make ASCII lowercase. There's 2 lowercase. That's kind of annoying. Is lowercase for each car. I don't want to do it for every car though. I mean, I guess, right? Like, that's a lot of cars. It is a lot of cars. I'm not super happy with that, but whatever. Actually, all of these don't need to be lowercase, right? If node is lowercase, path.iter all node cars. The path is the nodes we visited up till this point. If, what am I doing? If the node ID that we're trying to visit already exists in path is what I'm trying to do, but only if it's lowercase. So let's start with if it exists and node ID dot cars dot all car is lowercase. It's going to be like contains, isn't it? If the first character of a cave name is lowercase, it is a cave that can only be visited once. If it is already on the path, then the path is invalid. Yes. Which is why I'm returning 0 from this case. Expected string slice found stir. Weird. Okay. So now we're panicking at the assertion fails. If the path we're trying to get to contains the node ID and the node ID is lowercase, then it's an invalid path and we return 0, right? Yeah, I mean, I could flip these two, right? So like we could do this and path contains. Wait, no, that's not what I'm doing. Hang on. I need to think about this for a second. What I'm doing down here is I am starting off with the node ID in the vec already. So maybe we should start off with not doing that. We're pushing it in down here. No, that's right. That's right. That's what I want. So we start off with start, right? And the path is start. So if the node ID is end, like the next node ID, so this is the current node ID then. So if the current node ID is end, then we end and we return 1. Otherwise, if the current node ID is a lowercase, we know that the path already contains it, so we don't even need to do that check. Which means that this is not the right place for that. Yeah, current ID. Yeah, you're absolutely right about that. Next node's iter map. And then here, if node.cars.all c is lowercase and path dot contains node 0, else continue. So let's do debug node ID path allow. I don't want to do allowed ways here. We can always look at the other one. Borrowed here. Okay, so we've got this. And we start with start. And we try to add node ID A, right? So then we're adding start here. Why are we adding start here? That's why. Start bn sum. Okay, so we do start first, right? Where's the test input? Or maybe it would be better if I pulled over the Chrome window, actually, now that I think about it. I'll pull over the Chrome window. We can do it like this. Okay, so start A is valid, right? Start AC, start AC, start ACA, start ACAB, start ACABA, start ACAB end. So that should be a valid path, right? Start ACABD. Let's debug out the, while I'm here, right? While we're doing this, let's look at the actual value that's getting returned. Valid. Yes, valid, but also the value I'm getting back from this. Oh, you know what I might have done? Now that I think about it. I hard-coded 0 right here. So the test is failing because I hard-coded 0. The test passed. We're good. Whoops. Glad I caught that before I went through and tried to like actually debug this or anything. So the issue, the algorithm is right. The issue is that I was returning a hard-coded 0 for the test. So we are getting 10 paths for step 1. So what we're doing here is we call step with the starting node, the vec with the starting node in it. So this is the current path that we're following. And then the allowed ways. So that's the map from node to possible places you can go from that node. And then we call step, and notably this is recursive, so we're calling step inside of step later in the same way. If the node ID is end, then we return 1. I guess the other thing we could do here so we end up not needing the data structure setup that I did before with the empty array. Because we're not actually concatenating all of the paths. That would have helped us if we were concatenating the paths specifically, not if we were returning these numbers. So if it's end, we have a valid path. Otherwise, we grab the next set of nodes that we need to get to. We iterate over them. For each of them, we make sure that it's not a cave that is lowercase that we've already visited. Because if it is, then we have an invalid path and we return 0. Otherwise, we do the step again, which means that for each possible place we can go, we are now branching off into another recursive function for each step. So let's get the actual input. I felt like I made that harder than it needed to be. And maybe that's just because, like, I swear streaming takes up like a good 25 to 50% of your brain power, no matter what you're doing. I appreciate y'all in chat helping me stay on track here. Okay, cargo run, part 1. If this is incorrect, then we have work to do. We have other examples we can pull in. But it's not. Well, yeah, it's not incorrect, which means it is correct. We win. Yay. After reviewing the available paths, you realize you might have time to visit a single small cave twice. Fine. Specifically, big caves can be visited any number of times. A single small cave can be visited at most twice. And the remaining small caves can be visited at most once. However, the cave's name start and end can only be visited exactly once each. Thank you for that. Once you leave the start cave, you may not return to it. And once you reach the end cave, the path must end immediately. Now, the 36 possible paths through the first example are all of these. So 103 is our new test input for part 2. And I'm just going to copy and paste step because we're going to modify this. I'm going to call it step 2. Okay, so step 2, our conditions change, right? We need to now count the number. So if it's lowercase and the path contains the node, and how do we count this? Path.filter node equals, oh, I can't call it node. I have to call it path node. Path node equals node dot count. We also have to detect. Okay, so we have to detect if there is any other cave. So let's do this. Let's do, if it's lowercase and the path already contains node, then we have more shit to do. Let count of current node equal path.filter whatever dot count. So this filters path down to only the ones that match the current node. I guess the other thing we could do is like group it, like sort it and group it. I feel like there's an easier way to do that, but I can't think of it. We could build up a hash map and make sure that we only insert lowercase and then iterate over it and see if any of them are 2 yet. And if there isn't one that's 2 yet, then we continue. So let's do this. So we filter for all of the ones that are lowercase. In the path. And then we fold this into what? A B tree map new that takes an accumulator and an item, and this needs to be mutable. Is it mutable already, actually? I don't think it is. I think we need to specify it. Mute acc item. So acc.entry item dot and modify v plus equals 1 dot or. I hate these pop-ups. These pop-ups are so bad. Or insert 1. And then we return acc. So this will give us count of all small cave visits, right? And then we do if we visit any of them twice already, then we're done, right? KV where v equals 2, but have visited small cave twice equals this. Tell me I'm gonna have to do a reference here. I don't want to do that. Let's do it here. Okay, and then if we have visited a small cave twice, then we return 0. Otherwise, we continue. So this needs to be higher, right? This needs to be done here for every single pass. And then here we can do if node cars all C is lowercase and path contains node and have visited small cave twice and small cave already exists is path.contains node, then 0, otherwise we continue. Sick. What did I do wrong? Use size. Result. Use size. Not found in this scope because I changed the test input variable. Okay, so that didn't work. So let's see. What's the test here? Map, right? So we're mapping over the next node. If we have a lowercase cave, and the lowercase cave already exists in the path, and we've already visited some other cave, then it's 0, right? Otherwise we can continue. Is that wrong? Is that not what we're supposed to do? You might have time to visit a single small cave twice. So the number needs to get to 2. So it needs to be 1, and then it needs to be 2. Specifically, big caves can be visited any number of times. A single small cave can be visited at most twice. So if any cave that is small has been visited twice, and the remaining small caves can only be visited at most once. Actually, you know what it did here? As soon as we visited any small cave, actually, if we've already visited a small cave, and there is one that has been visited twice, then we're done, right? I feel like this is right, but it is clearly wrong. So let's do our debug. For node ID path. Let's just debug path, I think, actually. Can I not collect that into a string? That seems wrong. Do I need to explicitly clone this for some reason? That seems weird. Like we could into iter, but I don't really want to take ownership over everything. We'll just clone it for a second. We aren't using step 2. Yo, I need the Rust compiler. I need the Rust compiler for not calling the right function. Or like returning a silly error or something like that. That seems weird, right? One path? Yo, you know what I did? I'm trampolining out to step 2 for no reason. The slightly larger example above now has 103 paths through it. What do you mean the slight of 36? Okay, so I got the wrong test value. This is supposed to be 36. So we're good. That was the correct logic. It's just an extra condition to the if statement. Dang, the number of times today that I've just like not called the right function. That's literally my hang-ups today have been not calling the right function. Tell me this is gonna run for fucking ever. Yay, that's it. So to go back over everything that we did here, part 1, part 2. For part one, we did a recursive function called step. We passed in the current node and the sort of like bootstrap value. So the current path is the current node in a vec, and then all of the ways that we can get from one node to another. If it's an end, we return 1 because it's a valid path. If it's not the end, then we iterate over everything. If it's a lowercase character that we've already visited, that means an invalid path because we can't get out of that cave then. If otherwise, we continue with the recursion. For part 2, we need to include an additional check, which is all of this logic right here, which is checking to see in our path if any of the previous caves that we visited are lowercase caves that have been visited twice already. So if the cave we're trying to visit already exists in the path, which is what this contains checks, and there is some other small cave that has already been visited twice, then we have an invalid path. Otherwise, we continue with the recursion. And these are the same recursive algorithm in both cases. Yeah, so that's that. Let's do cargo bench to see how long these run. My logic for part 1 is exactly what you just explained. Oh well. If you want me to take a look at it, I'm happy to take a look at it. The benchmark for part 2 is going to take a while, isn't it? I wonder if there's any way we can speed that up. Like, we're doing an entire, what, fold for every single path? I also forget whether we're benchmarking on the... We're benchmarking on the actual input, not on the test input. So that's nice. I'm definitely not the, aside from runtime, I'm definitely not the fastest person to do advent of code stuff. These are not problems that I regularly encounter, like recursive graph traversal. Like, how many times do I actually write a recursive algorithm in Rust? Not very often. So part 1, part 2. If we run with the DAP profile, it's going to take even longer, so I'm going to do part 1 first. So massive amounts of memory usage. Just absolute, just tanker over here. I see your link, Nikki. And then I assume that part 2 is going to be even bigger. So we've got like 7 megabytes. And this one's a lot. Yeah, okay. We're allocating a lot of vecs, basically. So I wonder if there's a better representation that we can use when we pass these values down. A more compact representation, maybe. Because with the recursive algorithm, we do actually want it to like get a new thing each time. So when we do step or whatever, right? like this path, we want that to be a fresh thing each time. But it does result in quite a lot of heap allocation. So I wonder if there's a way that we can represent this that is like references to the characters in some way. I don't know. What's better than a vec for this? Doing it with the stack will be lower. Will lower the RAM. Yeah. I don't necessarily want to convert heap to stack. Right? I think I want to use a more efficient representation. Doing it with stack will be lower the RAM using. That will be the iters, yeah. I don't necessarily think that I just want to like take all of the, well, I guess we can clean it up. But like the recursion will keep it around, right? Until the end of the recursion. So in that case, I think in this, we build out all of them and then we come back up. So maybe there's something we can do like depth first and keep the other stuff around. Like we don't use that much at any given time, right? We only use 10 kilobytes at the peak of the program. We just generate a lot. So I'm not even really sure this is a problem, to be perfectly honest. 387 megabytes. But we're always writing only 10 kilobytes. At most. Like, I guess a more efficient representation would bring down the total, but does that really matter? I guess it would in terms of runtime, but in any case, I may or may not do that later. I'm not going to do it on stream. So we're kind of done here. Day 12. If anybody has suggestions, because this does feel very big, even though the runtime, like the benchmark for the runtime was only 600 milliseconds. So like if let's go cargo run bin to release, which we'll have to compile, but so I mean it runs in 700 milliseconds. It allocates 387 megabytes of memory, which is a lot. Like, don't get me wrong. But it only does it 10 kilobytes at a time, at most, which is kind of wild. Like, those are big numbers for it to be running in a couple hundred milliseconds. So, anyway, that's it for today. Thanks everyone for hanging out. It'll be the same time tomorrow. I still need to set up the schedule for this week. It'll be the same time all week that we've been doing the other weeks, so it'll be 10 a.m. PST. And I will catch you tomorrow. Thanks for hanging out.